Aloha. Before I start, I just want to thank Shaka Khan, Jason, Nani, Claire, also all of you for attending. Obviously, it's incredible to have a conference in Hawaii, but honestly, we couldn't do that without you, so mahalo. All right, so let's talk about exposing spies on macOS. My name, as Jason mentioned, is Patrick. I've worked for a bunch of acronym places. I'm currently the chief security researcher at Synack. So just very briefly, Synack does crowdsourced vulnerability discovery with vetted security researchers. So if you're interested in working with us to run a bug bounty program, or if you're a security researcher who'd like to get paid to find pretty easy bugs in our customers' web app, mobile apps, and IoT devices, check out synack.com. All right, so what are we going to be talking about today? So we're going to start with some background mic and webcam concepts specifically on macOS. And then we're going to start by looking at some Mac malware specimens that specifically had Mac and or webcam mic capability. So that is to say, once they infected a user, they would try to spy on the user by either turning on the webcam or the mic. We'll then talk about a relatively new attack or capability that could allow malware to actually record the user by piggybacking onto legitimate webcam sessions, and do this very surreptitiously so that the user would not be able to detect what was going on. And then finally, we'll talk about how to detect and thwart this attack and discuss a tool I wrote to protect Mac users against this. All right, so let's start by talking about some background concepts. Now, at least to me, I think one of the most insidious actions or attributes of a cyber attack is if the attacker or the malware records the victim or the user. I mean, you can hack my computer and steal my credit card. I will be bummed, call up my bank, get a new credit card, really no harm done. But if you, turn on my webcam or start recording what I'm saying as I'm walking around the house, I mean, that's a really more of a personal attack that really can have some emotional components attached to it. So who is doing this kind of hacking and spying? Well, first, there's hackers that are doing this. There's a great article a few years that discussed this online forum where hackers would kind of band together, and their main goal was just to hack users, specifically girls, and then once they had infected their computers, turn on their webcams to try to record them in private or intimate scenarios. So obviously, you can imagine for the victims of this attack, that's incredibly traumatic. There's also a Netflix show called Black Mirror. A lot of interesting episodes, but one in particular starts out with hackers hacking a young teenage boy's laptop. They then turn on his webcam and record him pleasuring himself. And then the rest of the episode is how basically far they can get him to do horrible things because they have this information on him. So again, very interesting episode, but all starts with the fact that they were able to hack his computer and turn on the webcam. Again, this is a fictional show, but I think has a lot of realistic scenarios. Of course, governments and nation states are supposedly doing this as well, but for different reasons, right? I don't think the NSA wants to see us naked. I mean, I'm assuming that. But they probably are interested in maybe what is going around your laptop or what is being said in the local proximity. So imagine Donald Trump has a MacBook. If someone hacked that and were able to turn on the microphone, they'd probably get a ton of incredible actionable intelligence. I mean, there'd probably be a lot of babbling and maybe some Russian discussions as well. But you can see it's a very awesome capability to have. All right, so shortly we'll look at some malware specimens that are able to spy on Mac users via the webcam or the mic. But let's talk briefly about how to do this programmatically. So how do you access the webcam or the mic on a Mac computer? Well, it turns out Apple has kindly provided us various foundation framework APIs that we can use. And the most modern, most recent one is something called AV Foundation. If you Google AV Foundation, you can find Apple's AV Foundation programming guide. And it's a great document that has examples, details about the APIs, etc. Now, as we can see on the slide, where it sits in the application software stack is really kind of in a perfect spot. It's above all the low-level complex APIs, so it really abstracts a lot of the complex details away, which is nice. But it's below the applications, which means applications can just link in this framework and use it very easily. Now, you might be wondering, okay, so an application or a piece of malware has the ability to turn on the mic or the webcam. Are there any indications? And we'll talk a lot about the LED indicator light. But other than that, does the specific piece of code, for example, have to ask the user before accessing the webcam and mic? And the answer is yes, but only if you're from the Mac App Store. So if you're from the Mac App Store or you're a sandboxed application, you have to have what is known as an entitlement before accessing the mic or the webcam. The entitlement is the com.apple.security.device.camera for the webcam. What an entitlement is just a cryptographically verifiable characteristic of the binary. So it's something that you have to basically tell the operating system that you support. And if you don't have this in your sandbox application, you will be denied from accessing the webcam and the mic. But turns out you can add this attribute, this entitlement yourself. So if you're building an application from the Mac App Store, you just go in Xcode, you check the box that says camera, and this will add the entitlement. I guess the idea is Apple will then verify, if you're a calculator application and you have webcam capabilities, Apple might reject you from the Mac App Store, but I really doubt Apple really does anything. And in terms of malware, the majority, I would say 99% plus of Mac malware is distributed outside the Mac App Store. And if you're distributed outside the Mac App Store, you don't have to have any entitlements. So this means once code is running on the box, it can access the mic or the webcam with no pop-up to the user. Right? On iOS, you might get a pop-up saying, hey, this app is trying to use your mic or trying to use your GPS locations. There's none of that on the Mac, unfortunately. Okay, so now let's walk through a simple example of how to programmatically record both off the mic and the webcam. Now, this is based on an open source project called VideoSnap that's available on GitHub. So if you want to go home and write some webcam-aware malware or just test this out, you can grab this code from there. So this is the main file. We do two things. We basically set up a signal handler, and then we create the VideoSnap object. The signal handler is just there. This is a command line application. When the user hits Command-C to exit the app, we want to catch that so that we can flush out the video capture to disk. So the VideoSnap object is what actually does the recording. And you can see we do this recording in about 10 lines of code. So we do basically 4 things. We first get the default video device, which is the built-in webcam. We then create a capture session, an AV capture movie file output, and AV capture device input object. And then we add these input and output objects to the capture session, and then we call start recording output to file URL. The end result is the webcam will now be pulling images off the device and writing it out to the file we specify. Again, the LED indicator light will come on, which is a good thing. But again, this shows you how trivial it is to actually record off the webcam. Now, as I mentioned, we have to add some code when the application or the command line utility is exiting just to nicely flush everything out. So we do this in the signal handler. Basically, we call stop recording. And then this calls an OS delegate function that we can implement, capture output. And here we basically call stop running. And that just allows AV Foundation Framework to flush everything out and close the file. So on the bottom of the slide, you can see we've compiled and executed the command line application, and it begins capturing off the webcam. It's going to find the default webcam, turn it on, and start grabbing files or frames. Then until the user hits Control-C, just going to keep capturing. And then when Control-C is hit, it detects that in our signal handler, flushes that out to disk. And we're left with a nice QuickTime movie file that is the recording off the webcam. So again, really easy to do. Now, if you want to add audio capabilities as well, this is just as easy, if not even simpler. Again, you use the AV Foundation. You create an input device, and you tell it that you want of type audio, and this will return you the default built-in microphone. And again, once you execute this, it will create not a movie file, but an audio file. Now, as we can see on the slide, one issue is that there will be no indication that the mic has been activated. So if you write a piece of software that turns on the microphone and starts recording, basically turning on the device, turning into a hot mic device, there's no indication to the user. There's no pop-up, there's no LED indicator light. So my Mac could be hacked right now and something could potentially be recording me. I would have no indication that that was going. So that's, in my opinion, a little worrisome. All right, so we briefly discussed this already, but when people talk about webcam hacking, it's really often all about the webcam LED. Luckily for Mac users, not so much for the hackers, on modern Macs, the LED indicator light is separate from the operating system, kind of decoupled from software by design. So it's implemented in hardware and kind of isolated. So there's a question someone asked on Reddit, basically, is it possible to hack? And the short answer is essentially no. It's very difficult. Now, of course, if someone had physical access, they could probably pull it off. But if there's an advanced adversary that's targeting you specifically or your laptop, turning on the webcam is probably the least of your worries. Now, however, this wasn't always the case. So in 2008, older MacBook models were found to be vulnerable to an attack that would allow the webcam to be activated and record the user without the LED indicator light going on. So this was done by some researchers at Johns Hopkins University. They wrote and released a paper titled ICU Disabling the MacBook Indicator LED. And they basically had two pieces to this paper. They described the architecture of the webcam and then described an attack that allowed them, as I mentioned, to turn off the indicator light but still pull capture frames off the webcam. So here you can see we have the architecture. It's basically 4 parts. The host computer talks to an internal USB microcontroller. This is a Cypress Easy USB microcontroller. The USB microcontroller then talks to a Micron image sensor via I/O pins. And the image sensor is actually what is capturing the frames. Now, attached to one of the I/O pins is the LED indicator light. Specifically, it's attached to the standby pin. So when standby pin is on, meaning the device is in standby, meaning there's no power, the LED indicator light is off. When the standby pin is off, meaning there is power going to the device, the LED indicator light is on. Pretty straightforward. What their research found, and it was great research, but they actually found a pretty straightforward attack. They basically found that from user mode, code, even without root permissions, could reprogram the USB controller. They specifically could send a firmware load request to the microcontroller and upload new firmware. Once the malicious firmware was on the micro USB controller, it could do 2 things. The first thing it did is it told the standby pin to always be on. So basically, this would tell the LED indicator light to always stay off because it always thought the image sensor was off or not getting powered. It then told the image sensor, though, to ignore that standby pin. So end result was the image sensor would be still sending files back to the USB microcontroller, basically capturing files off the webcam, but the standby pin would always be on, so the LED indicator light would never go on. So again, end result, any user, any malware could activate the webcam, record the user without the LED indicator light going on. Apple has fixed this. I'm not sure the exact details, but I believe either the firmware now has to be signed, or it's completely separate and cannot even be updated from the operating system, which is what I hope they did. Okay, if you now are worried about your webcam, though, there's a few things you can do. And the first one, and probably the best, is just to physically cover this. It's a very low-level prevention mechanism, but it's what the FBI recommends and actually is the best thing to do, in my opinion. So you can use tape. That gets a little annoying if you're pulling tape on and off all the time, if you want to use your webcam legitimately. So you can also use a webcam cover. I actually have some and some t-shirts, so at the end of the talk, I'll be handing those out. Webcam cover is just nice. You just slide it over your webcam when you're not using it, and then slide it off when you're, for example, having a video chat or a meeting. Now, you can also do this via software. I don't really recommend this, but these instructions are out on the internet, so I briefly wanted to discuss them. Basically, the idea of this is you just make all the plugins that the operating system or applications use to access the webcam, you make them inaccessible. So you set the permissions, so for example, FaceTime can't actually load or read the plugins. End result is the webcam is kind of disabled. Now, in my opinion, there's 2 problems with this. First, any malware that gets on your system, if it has the necessary privileges, can just change the permissions of these plugins back. Or it can even circumvent the plugins, perhaps directly talk to the lower level webcam interface and bypass this altogether. So I don't recommend this kind of solution. Okay. So that was some background webcam and mic-related concepts. Let's now talk about some Mac malware that attempts to record users via the webcam or the mic. Now, one thing to note about all these samples is, in my opinion, they're kind of lame. And they're lame because they will independently initiate webcam sessions to record the user. And this is obviously, in my opinion, a dead giveaway, right? Like if you're sitting at your computer, minding your own business, and all of a sudden the webcam light goes on, I'm taking that laptop and throwing it out the window. So it's kind of a dead giveaway that something suspicious is going on. But apparently not all users notice that, or it's something that malware is still doing. Okay, so the first piece of Mac malware we're going to talk about is Oxs Crisis. This was Hacking Team's Mac implant. So Hacking Team was, or I guess still is, an offensive cybersecurity company from Italy that sells their products to a whole bunch of shady governments. Luckily, or interestingly, they got spectacularly hacked a few years ago, and the source code for all their products got released. So this is nice because we actually now have source code for their Mac implant. So we can build it. I wrote a blog how to do that if you want to play around. Makes it very easy to analyze. So for example, we can see it persists as a launch agent, has a rootkit component, and most interestingly, it has a whole bunch of different modules that allow it to capture all sorts of interesting stuff. So it can pull stuff off the clipboard, it can access files, calendar data, Skype stuff, and of course webcam and microphone data. So here you can see the code responsible for accessing the webcam. They implemented this in a file called rcsm agent webcam.m. It doesn't use the AV foundation. Instead, it uses an older deprecated Apple framework called Qt-Kit. But Qt-Kit still works. Here's the code, few lines. You can see it'll access the webcam and start recording the user. Again, the LED indicator light will come on. Interestingly, they have a completely separate module for the mic. These guys, Hacking Team, are decently sophisticated, so they probably realized that turning on the webcam is a dead giveaway because the LED indicator light will go on, but the mic can be turned on without any indication. So again, they decoupled these two components out, so perhaps if a target is a little more wary, they could just turn on the mic capabilities and record what is being said around and collect all sorts of very interesting information without alerting the user that their computer is infected. So here there's the code for that. Again, they're not using AV Foundation. They're using something called the Audio Queue Services, which is a C programming interface that Apple provides. Again, it's just an older, lower level API that allows you to access the mic. My guess is this code is now about 10 years old, and at the time, those were kind of the APIs and frameworks that people were using to access the mic or the webcam. More recent Mac malware sample is Eleanore. Eleanore was distributed outside the Mac App Store, but on a popular app sharing website called macupdate.com. So what happened is the malware authors realized that there was this fairly popular application called EasyDoc Converter, and EasyDoc Converter was abandoned by the author. So what they did was they wrote a new version of this EasyDoc Converter and installed or added some extra malicious code. So it's basically a Trojanized malicious document. As I mentioned, they then uploaded it to macupdate.com. Macupdate.com didn't scan the file or allowed it to be listed and hosted on the site. So then any user that then went to look for an image conversion utility and downloaded EasyDoc Converter, when they ran it, they would inadvertently have infected themselves with Eleanore. So kind of an interesting attack or infection vector. Eleanore basically exposed a PHP backdoor and then communicated over Tor so that the remote adversary could command and control an infected Mac computer. Now, one of the interesting things is this malware was distributed with a few precompiled utilities. For example, Netcat and something else called WhatCAW. Now, WhatCAW is an open source webcam capture utility, which now gave the Mac malware authors the ability to record the user. So they would package up their malware with WhatCAW, and then they could give commands via the PHP backdoor to execute that and start recording the user via the webcam. Again, though, the LED indicator light would come on. Next up, we have OSX Mokes. This was a rather sophisticated, very feature-complete backdoor that was detected last year by Kaspersky. It was mostly interesting because of the features it had. So it had ability to search for Office documents, do screen captures, webcam and audio, and also monitored for the insertion of USB devices. This is rather interesting. We don't see this a lot in Mac malware. So again, always hard to attribute things, but this looks like a piece of malware that was perhaps written by a nation state or some state-sponsored hackers who are interested in surveillance gathering versus just pure cybercrime. So if we look at the disassembly of the malware, we can see it uses the Qt framework to capture video. Now this makes sense because Mokes is actually a cross-platform piece of malware. So it's designed to run on both Windows and Mac. So it makes sense then that the malware authors would use a cross-platform framework that would abstract the OS specific details about accessing the webcam. Obviously, you access the webcam programmatically different on Windows versus Mac. But using this open source cross-platform framework, they could call the same API, and the framework would take care of all the details. Again, though, the LED indicator light will go on. All right, so the last piece of Mac malware I'm going to talk about is FruitFly, and this was detected at the beginning of the year. It was actually the first Mac malware sample from 2017. And it's actually a very interesting, unique backdoor. For one, it's written in obfuscated Perl, which again, we don't see a lot of Mac malware written in Perl. It's a very kind of archaic language. It also does things like probe other devices on the network, maybe perhaps trying to propagate or talk to other infected devices on the network. And again, this will persist as a launch agent. In terms of the webcam capabilities it uses an incredibly old API or framework called Apple's QuickTime APIs. It's actually really deprecated and took a while for me to get working. I wanted to write a proof of concept using the QuickTime APIs. So first, Apple has removed the header files from the more recent versions of the SDK, so you have to go back a few versions to get that. Then the library is only 32-bit, so you have to build an application or code that is 32-bit. But once you do this and link against all of that, the application will execute and will allow you to record off the webcam. Of course, the LED indicator light will go on. I'm actually giving a Black Hat talk about this specific piece of malware. I wrote a custom command and control server that allowed me to analyze the malware by simply tasking it versus reversing it via disassemblers and debuggers. The most interesting thing then, I noticed one of the backup command and control servers for this was available for registration. So I registered it, stood up my own command and control server, and immediately had hundreds of infected Macs connected to that. I was very tempted to build my own botnet, but I didn't. But anyways, I'll be talking about that at Black Hat, so if you're there and interested in that kind of stuff, hopefully see you at my talk. Okay, so that was some recent Mac malware specimens. Hopefully illustrated that yes, Mac malware exists, is a reality, and is actually decently sophisticated, at least in terms of the capabilities or features that they have. And hackers and nation-state malware authors are creating Mac malware that has the ability to turn on the mic or record users off the webcam, which is, I think, somewhat worrisome. Now, as we showed or we mentioned, all these specimens, though, will initiate the webcam session. So again, the LED indicator light will go on. Again, I think that's an incredibly big giveaway. So putting on our black hats for a minute, I want to talk about an interesting attack that I discussed last year, late last year, basically showing that we can wait simply until the user initiates a legitimate webcam session and then piggyback onto that to record that surreptitiously, and that won't trigger any secondary indications to the user. So the first observation that I think is important to make is that Mac users do use their webcams for legitimate purposes. For example, business meetings, right? If you're a remote employee, you might dial in to talk, about acquisitions or, work stuff. R&D team, again, might be doing some remote work, so you might have FaceTime sessions or Skype. Talking to journalists, for example, I often talk to security vendors, maybe Apple security team about some security vulnerability or issue or malware I found. We can do that over Skype or FaceTime. And finally, a lot of end users use FaceTime for perhaps intimate FaceTime sessions. And any given week, I probably do 3 of these. You're gonna have to guess which 3. But again, the interesting thing is this is probably what the hackers or the nation-state attackers want to be recording anyways. Imagine someone hacked my Mac and found a way perhaps to turn off the LED indicator light. If they recorded me all the time, they would see me at my desk like picking my nose or like petting my dog, right? That's really not interesting. What they probably want to record, though, is when I'm talking to Apple security team about a 0-day vulnerability, or when I'm talking to my company about some maybe new acquisition we have. Again, if it's a hacker, again, they might be probably most interested in those intimate FaceTime sessions. So again, that's when the user is actively using their webcam. So again, that's probably what the nation state or even just normal hackers are most interested in anyways, is these sessions when the user is legitimately using the webcam. So what conceptually we're gonna do, it's actually pretty easy, 3 steps. We're just gonna wait until the user is legitimately using their webcam, any reason. Then we're going to detect this and piggyback onto that session to record off the webcam. And then we can exfiltrate this data, obviously, to a command and control server. So we'll focus on number 2, the detection and piggybacking, because that's really the most interesting, unique part of this attack. So the first thing we do, or the malware does, is enumerate the camera. And we talked about how to do this via the AV Foundation, but again, pretty easy. You just invoke the AV Capture Device class method, and you pass in the devices with media type AV media type video. Basically tells AV Foundation, give me all references to attached devices. Now this will turn an array of attached webcams. So if you have 2 or 3 webcams attached, it'll return 2 or 3 items. What you can then do is iterate through all of these. You can find the default one, you can find the built-in one. End result is you have reference to the webcam device. So once we have a reference to the webcam, the one that the user is going to use, we can register for notifications. And we'll register for the on-off notification. And we do this via the CMIO object add property listener block method or function. And this function takes a few parameters. It takes a connection ID, which is just identifies the device we're interested in, and we pass it the connection ID for the default webcam. It then also takes information about the notification. We tell it we're interested in the on-off notification. And then finally, we pass it a callback, which is just a chunk of code that will be executed when the notification triggers. So what does our notification handler actually do? Well, the first thing it does is it queries the webcam to figure out the existing state. And the reason we have to do this is there's not 2 notifications for on or off. There's just 1 notification for when the webcam basically changes its state. So if the webcam is going off, that's really not interesting to us. We're only interested when the webcam has been activated by the user for a legitimate webcam session. So we can do this. We invoke the CMIO object get property data function, and this sets a variable to a 1 or 0, 1 meaning the device is on. And then if the device is on, we know, hey, the user has just initiated a legitimate webcam session. Now we can piggyback onto that because the LED indicator light is already on. So once we've detected the webcam is on, we can simply start recording via the standard AV Foundation APIs. And you can see it's about 5-10 lines of code. And the reason this all works is because the webcam is a shared device. It's a shared resource, right? So you could FaceTime, Skype, photo, chat, whatever, all at the same time. It's just modern applications expect devices such as the webcam to be shared. So this means the malware can also record off it as well. So this is kind of why the whole situation works. Now, it's equally important to also detect when the legitimate session is ending. We'll talk about in a minute how to detect or identify what process is using the webcam, for example, Skype or FaceTime. But assume we know what application activated the webcam originally, what we can then do is monitor it to determine when it exited. And the reason we need to do that is, again, imagine you're having a FaceTime session with your partner, and you're done and you turn off FaceTime and the webcam light still stays on. Like, that would be very, very, very suspicious. So what we can do is we can generate or register a notification handler that tells the operating system to invoke us anytime an application exits. And in this notification contains the path and PID of the application which just exit. So we can do a stir compare and say, hey, was this the application that initiated the legitimate webcam session? So for example, if it is, we then know that as the malware, we should stop recording as well so that we don't hold the LED indicator light on. So from the malware's point of view, this is actually a pretty awesome attack. Why? Well, first, it uses legitimate functionality of the operating system. These are my favorite kind of bugs or features to abuse. This isn't something that Apple can easily patch out. We're just abusing the fact that the webcam is a shared resource, as I think it should be. You also don't need root to pull off this attack, so malware executing as the normal user is able to pull off this attack without any special privileges. Can also always record. So when I use my webcam, it's not to record myself. That would be kind of narcissistic. It's to usually broadcast myself to somebody else. But the webcam doesn't make any differentiation between broadcasting and recording. So even if the malware is recording you, even though you're just broadcasting yourself, that's fine. There's no other indication about that. And then the most important part is the LED indicator light is already on. So there's no other indication that the malware has surreptitiously piggybacked onto the stream and now is recording you. So as an avid Mac user, this bothered me. Basically, I wanted to know if perhaps there was some malware on my system that was perhaps piggybacking onto all my webcam sessions and recording me. So there were some tools already out there that would tell you when the webcam went on, which I think is kind of pointless because the LED indicator light goes on as well. But there was no tool that would tell you what process was using the webcam, which I think is interesting because if you were infected with one of the pieces of malware I talked about before, if that webcam light all of a sudden comes on, you probably still want to know why or who triggered that. And then most importantly, there was no tools that were able to detect this piggyback kind of attack. So I decided to write a free utility that could selfishly protect my computer, but then also other Mac users as well. So the goal of the tool is pretty basic. Basically, it does 3 things. And again, the goal is for it to basically alert us anytime anything uses the mic or the webcam, and then tell us what application or process this is. And then if anyone piggybacks onto that session, also alert me of that fact as well. So we'll go through these, but basically 3 steps. We monitor for mic and webcam usage. And then we identify the consumer process, or the process that is responsible for triggering the use of the webcam. And then while the webcam is in use, we monitor for new consumers. This might be legitimate if you're FaceTime and Skyping at the same time. I don't know why you would be, but it's more likely something suspicious. But again, the application will tell you what is piggybacking on, and then you can block or deny it. So the tool is called Oversight, mentioned 100% free. And again, these are the goals. I just wanted something to alert me when the mic or the webcam came on. I realize some users will still just click allow, but it also logs everything. So for example, in a corporate or enterprise environment, a sysadmin can perhaps analyze the logs reactively and see that the user allowed something to access their webcam that they shouldn't be. So how does Oversight work? Basically, there's 2 components. There's a login item and an XPC service. The login item runs in the context of the user's session, basically just creates a little icon in the status bar, and it does 2 things. It monitors for the audio and video change notification, and then generates or displays the alert to the user because it's running in the context of the user session. Now, there's also a higher privilege XPC service. XPC is just an IPC mechanism, how you do some message passing. And the reason it needs to be privileged is for 2 reasons. First, in order to find the consumer process or identify what application is using the website or webcam, we have to do some low-level querying of the operating system. Talk about that on the next slide. And then it also needs to be running at a higher privilege so that it can kill the process if the user decides to block it. So say there's a piece of malware running as root that turns on the webcam. Oversight will detect that. If the user clicks block, we need a piece of code that's running as root as well so that it can kill the malware that's running at that privilege level. So one of the main features of Oversight is the fact that it can identify who is using the webcam and the mic. So it turns out this actually is not easy to do. So yes, the operating system will give us a notification saying, hey, the mic or the webcam has just been activated or deactivated, but in that notification, there's no information about what application triggered that. Is it Skype or FaceTime or Siri, or is it some new piece of malware, or is it something piggybacking on in the background? Turns out, though, we can still figure out how to identify that, even if the operating system doesn't provide us a direct way. So it turns out anytime code accesses the webcam or the mic, the operating system sends a mock message to the camera assistant process. Mock message is just an inter-process IPC message that has some information. So what we can do is we can monitor for these mock messages by basically observing who is sending these mock messages to the camera assistant process. Once we have that, then we can also examine that process. We can see what libraries it has loaded. We can look at a thread or stack backtrace to see what the code is doing. And via this method, we can very reliably identify what application or daemon or code or script is accessing the webcam. So version 1.0 I released last year. It was fairly popular. I think the coolest thing was, for a minute, if you Googled Oversight, it was the first hit above the Government Oversight Committee, which is not that surprising because I don't really know what the Government Oversight Committee is doing, especially these days, but yeah, thought that was cool. However, it also had some limitations. For one, yes, it would alert you that the microphone was being used, but it didn't actually tell you why, or for example, what process. It also had no whitelisting, which was kind of annoying. If you use Skype or Siri all the time, you had to click allow each time. And then there was also some other UI issues. So recently I released version 1.0 to kind of fix or add these new features. So the coolest thing about version 1.1 is that it can now tell you what process is using the mic. So again, now when the mic is activated, you get a pop-up, and it'll also tell you what process or application triggered that. Again, there's no direct way to figure this out, but similarly to when something uses the webcam, the operating system will send a mock message. For the mic, it sends it to the core audio daemon. So we can basically sniff or watch who's sending mock messages to the core audio daemon. We can also query the I/O registry for clients that are using the mic. So with that, we can get a really accurate idea of what process is using the microphone or why it was triggered and turned on. Version 1.1 also supports whitelisting. So now, for example, if you're using FaceTime or Skype, you can basically say, I trust this, I allow this forever, which is really nice because it got annoying to basically click allow each time you Skyped or used Siri. Okay, so since we have some time left, I briefly want to talk about an interesting case study where Oversight was actually able to reveal that legitimate application had some very interesting behavior. So it all started when I got an email from an Oversight user. He said, thanks to Oversight, I was able to figure out why my mic was always spying on me. Just to let you know, the Shazam widget keeps the microphone active even when you specifically switch the toggle to off in their app. Scary. I was like, this is kind of interesting. At the time, I was stuck on a 15-hour flight, which sucked, but this gave me something interesting to look at, right? I do like kind of working on flights because there's no internet, so I really find I'm way less distracted. So before I hopped on the flight, I downloaded Shazam, and we are all probably aware of what Shazam is, but in case not, it's an application that can identify what song is playing. So we probably have it on our phones, but there's also a Mac app, and we're going to be talking specifically about the Mac application. So the idea is if there's a song you're hearing in the elevator or on the radio, you push a button and say, what song is this? It'll listen for a minute and then identify the song. Actually, kind of a cool thing to do. So I grabbed it, as I mentioned, from the Mac App Store, installed it, and when I executed it, Oversight said, hey, the mic is turned on, and it's Shazam. Really no surprises here. This is what Shazam does, right? Turns on the mic to listen so it can identify what song is being played. However, when I turned Shazam to off, I never got a deactivation notice. So Oversight will tell you when an application is using the mic or the webcam, but then also when it relinquishes that or deactivates that. So this was odd. And I thought, OK, my code might have a bug in it, or Shazam might still be listening. Either way, I wanted to dig into that. Again, stuck on this flight, had a lot of time. So I started by trying to understand the different pieces of Shazam. Whenever I reverse engineer an app or some code, I think it's always good to understand what each component does. So when I installed Shazam, the first thing I noticed is I got a pop-up from BlockBlock. Talk about BlockBlock in a second. It's basically an application that I wrote that monitors persistence locations. So this basically meant Shazam was installing something so that it would be automatically started every time I logged in and into my Mac. So I dug into that. Turns out just a login item. There's a great blog that describes how this all works. Basically, if an application has a signed item in the library/login items folder, this will be automatically executed by the operating system when the user logs in. So like Dropbox uses this, Google Chrome. This isn't really anything suspicious. It just was like, OK, this is how Shazam basically starts when you log in. So I took a closer look at that. There's the disassembly for that login item, and then also the pseudocode, which is probably easier to read. Pseudocode, you can see it doing two things. It creates a URL, Shazam mac://launch, and then executes that. And this turns out that to cause the main Shazam application to be executed. Now, I was wondering, why does executing this URL trigger the main Shazam application to be opened? And it turns out the main Shazam application has some information in its info.plist file that basically tells the operating system, hey, I'm a document or URL handler for type Shazam mac://. So if any application opens a URL of that type, please launch me because I will handle that. So if we dump the info.plist file, we can see it's basically registered as a URL protocol for that. And again, this is all just legitimate functionality. This is a way that applications can talk amongst themselves via custom URLs. OK, so now we basically just know how Shazam is started, and we know it's automatically started every time the user logs in. So recall, again, our goal is to figure out what is happening, or rather what is not happening, when the user toggles the switch from on to off. So luckily for macOS binaries, there's a lot of interesting information that is compiled into the binary. So if you run a utility such as class dump, it'll dump all the instance variable names and method names that were in source code. So for example, we can see a method called toggle auto tagging. So I thought, okay, this is probably something to do with toggling the tagging or the listening. So let's set a breakpoint there and see what happens. So you can attach this Shazam application, or you can execute it directly in a debugger. LLDB is kind of the de facto debugger on macOS. We set a breakpoint on that toggle auto tagging method, and then we hit C to continue. We go up in the status bar and turn Shazam from on to off, and lo and behold, our debugger breaks. So this means, okay, we have the right breakpoint, and this is the code that, yes, is executing when the user toggles the switch from on to off or off to on. Since we're broken in the debugger, we can dump various registers to see what values they have. In Mac OS on 64-bit systems, I have a table of what various registers hold at the breakpoint of an Objective-C call. Most important is probably the first argument in RDX. And we can see this is something called the IT switch class. It's just an object that Shazam uses to represent that toggle switch. But since we have access to that in memory, we can invoke methods on it. For example, we can invoke the isOn method, which comes back and says no, which makes sense because, again, we just toggled from on to off. OK, so we're at the right piece of code. We're basically at the Shazam application. We're at the chunk of code or method that will get executed when the user toggles the switch from on to off. So let's dive into figuring out what goes on under the hood. Basically, it calls a whole bunch of different helper functions. Most important, though, is at the bottom of the slide. Specifically, it calls something should stop recording when tagging ends. And then if that returns true, it calls stop recording. So let's take a closer look at that. So if we look at the stop recording method, we can see that it stops recording. Specifically, it calls an Apple API, which will turn off the mic and relinquish control. So, all right, looks decent. Remember, though, stop recording is only invoked if the should stop recording when tagging ends returns true. So let's look what that method does. If we disassemble that, it's the easiest of methods. It basically does one thing. It returns a Boolean yes or no if some tagging type variable is set to the number 2. So we can set a breakpoint on this method call, and when this method call gets invoked, when the user toggles the switch on to off, we can dump the value of this tagging variable to see what it is. And if we do that, we can see it set to 1. Since it's not set to 2, this means this method will return false. And if this method returns false, the stop recording method will not get called. So this means that Shazam perhaps is still listening. Now, when I reverse things, yeah, it's sometimes tough to be 100% sure, right? I didn't want to get all worried and freak out and email a nasty email to Shazam. So I dug around a little more to figure out why is this tagging type set to 1 versus 2. Maybe it was because I was on an airplane with no internet. Maybe it was because I was debugging it. Turned out, though, this tagging value is hard-coded to 1, meaning it's never going to be 2. And also, since we're in a debugger, we can query various methods on the Shazam application. And there turns out there's one that's called isRecording. So we can invoke this method, and it returns yes or true, even when the switch is toggled off. So basically, Shazam is telling us, yeah, I'm actually still recording, even though we've toggled this off. All right, so I was confident that Shazam was still actually listening, even though the user had toggled this off. I emailed them, and they came back and said, yeah, it's a functionality. Basically, their justification was, all right, imagine you're using Shazam, and you turn it off, and then you come back 10 minutes later because a new cool song is on, and you want to figure out what it is. If we had just turned off Shazam, it would take us 3 or 4 seconds to tell you what song that was. Whereas if we were listening the entire time, when you turned it back on, we could tell you right away what was playing. And I was like, okay, guys, so it's a feature, not a bug. And they're like, yeah. So I blogged about this. And briefly, really, I can go either way on this, if it's malicious or not. I do want to point out that they actually stop sending data to the cloud once you turn it off, but they are still recording off the mic. And also, based on the type of information they're pulling, you may not be able to fully construct full sentences. They might just be doing some sampling. But the issues still remain that, yes, they continue to record off their microphone even when you turn the app off. So as I mentioned, I wrote a blog about this, just kind of from a technical point of view. I really try to stay away from any issues or making judgments. Of course, the media, as they do, like former NSA guy figures out Shazam's always listening. Good news was this caused Shazam to do a 180. So, I guess all's well that ends well. Basically, Shazam said, okay, yeah, we're getting some bad press now. We should really turn off the mic when the user turns off, which is what I think they should be doing. So happy ending, hooray for Oversight. Okay, so let's wrap this up. I just briefly want to talk about generic detections before we end. The reason is, well, first, generic detections can be, I think, incredibly powerful. For example, the generic detection that says, alert me anytime the mic or the webcam goes on, can help detect even new Mac malware that perhaps spies on users, but it can also reveal shady or interesting capabilities about legitimate applications. For example, Shazam, right? An AV product is never going to flag Shazam, especially because it was from the Mac App Store. But via generic detection, we can say, hey, Shazam is still keeping the microphone on. So the first generic detection I really like is monitoring persistence. Persistence is just how malware installs itself so that it's automatically executed when the operating system starts. And basically, regardless of the type of malware, this is a commonality of essentially all malware. Now, they persist in different ways, but if we can write a tool to monitor these persistence locations or enumerate what has been persisted on our computer, we can detect new malware, even if there's no signatures for it. So I wrote two tools, block and knock. Knock is kind of like auto runs for macOS, tells you everything that's persistently installed on your box. Block will monitor the locations and tell you when something is trying to persist. Another tool I wrote is called a Ransomware, and this basically just watches the file system for the rapid creation of encrypted files by untrusted processes. This is something, again, all Mac malware does. So this tool is actually able to generically detect all Mac ransomware, even the most recent samples that came out after the fact that this tool was released. So again, all these tools are free, so I really hope this doesn't sound like a sale pitch. Again, I selfishly write them to protect my Mac and then figure, it's a little thing to do, sharing is caring. I also blog about a lot of Mac security vulnerabilities and Mac malware that I analyze. So if you're interested in Mac security, check out objectivec.com. All right, so I think we're pretty much POW. Are there any questions? And also, again, I have T-shirts and webcam covers, so if I will be up on stage around here after the talk. So if you want some free T-shirts or webcam covers, come chat. So I think we have a few minutes for questions, and then I think it's break time. Yes?
Have you checked out anything with the Google Home or Amazon Echo, like Dabble, to see what it's picking up and listening?
No, the question was, Google Home, Amazon Echo, like what are they hearing, what are they listening? I think for them, they're pretty overt. They're like, yeah, we listen to everything. There was an article, I think, a few days ago where there was a domestic dispute, I believe, in Arizona, and the boyfriend or husband was like beating the crap out of the woman, and they're like, someone said, did you call the sheriff yet? And Alexa or Google Home heard that, called the sheriff, and actually called the cops, and they showed up. And luckily, in this scenario, that was a good thing because they really were able to, prevent a domestic dispute. But of course, that means, what else are they gathering? So I personally do not have those in my house. I'm sure they're great listening devices. I'm sure hackers and nation states also see them as great listening devices. So if you're concerned about your privacy, I would recommend maybe not having those in your house.
Give them away as gifts.
Yeah, maybe put a little extra thing in and then give them away. Great question. Any others?
Is Siri running all the time?
I think it depends how you configure that. I think you can configure it to either hotkey activate it, but I think if you have it listening for OK Siri, that means it's, I think, always listening because it has to hear when you say OK Siri. Apple says, we don't store anything, and I'm sure they don't. But again, if I'm an attacker and I infect a Mac, I might inject code into Siri and then leverage that to, always be making a copy of what is recorded and exfiltrate that out myself. So again, these auto-listening things, they kind of worry me.
Yeah, my wife's an Apple user, Apple iPhone, and I'm an Android user. So she's always cursing her Siri. Shut up! Damn it, I didn't ask you anything.
Maybe you'll get a visit from some angry Apple employees one day. Yeah, do you have a question?
Oh yeah, I was just wondering if you had looked into seeing if you could run that on the iPhones.
Okay. Yeah, the question was, can you run something like Oversight on the iPhone? Unfortunately, no, because of the limitations of the app sandbox. So apps can't even see what other apps are doing. But luckily, I believe on iOS you need certain entitlements. So if an application, for example, wants to use the mic or the camera, there's a pop-up. So I think iOS actually has some built-in privacy things. Fortunately, people will probably still click yes. And if a nation state has jailbroken your phone and installed some sophisticated malware, it'd be still really nice to know if something was going on in the background. Awesome. Well, again, thank you so much for attending my talk and coming all the way to Hawaii, or if you're local, awesome. Mahalo again, and hopefully see you all next year at ShakaCon 2018.